there! Max and I are going to explore Pascal's triangle today. People have known of Pascal's triangle for over 2,000 years, long before Blaise Pascal got credit for discovering it. In this video, we are going to show you how to construct Pascal's triangle and how to explore some of the neat properties of the numbers in the rows of the triangle. Now that announcement is out of the way, let's get right to it! Hey Max, what you doing?
Oh hey Fumie, I was just sitting here admiring this triangle I learned about last weekend. I just can't get over all the cool things I see in it.
Why are you getting so excited about a triangle? Didn't you already know about triangles? We learned about those years ago. A three-sided polygon, interior angles add up to be 180 degrees and
Not that kind of triangle. I'm talking about the most famous triangle ever, Pascal's triangle. It's a neatly arranged stack of numbers in the shape of a triangle, but I really like how this triangle of numbers is made.
Oh, never heard of it. And that's it?
Yup. Isn't it something?
Okay, yes. It's definitely a thing. Something, I mean.
No, seriously, look at it. What do you notice?
Oh, Max, I don't know. There are ones down the sides of your triangle?
Okay, anything else?
Oh, there is symmetry because the numbers in each row increase until you reach the center, and then they drop back down to 1 in the same order they increased. And here, a diagonal that looks like 1, 2, 3, 4. Maybe you are right. Maybe there is something interesting about it. How do you decide which numbers go in this triangle?
It's super easy to construct. Start with a 1 and imagine invisible zeros on either side of it. Add them together in pairs and you'll generate the next row, and we do that again and again into infinity.
Well, that's not intimidating at all. So after this row, the fourth row will look like 0 plus 1 equals 1. 1 plus 2 equals 3. 2 plus 1 equals 3. 1 plus 0 equals 1. Okay, this is really cool.
Yeah, and like I said, the triangle goes on forever. There's no end to it. We just follow the same pattern. What else do you notice?
I guess because of the way we create the triangle, the rows alternate between having an odd number of entries and an even number of entries. Oh! And each row has symmetry.
What do you mean?
If I draw a line down the middle of the triangle like this, I get symmetry of the numbers. The numbers on the left side are a mirror image of the numbers on the right side. Oh, and look! On rows with an odd number of entries, the number in the middle is always even. Like here, 2, 6, and 20. Plus, all the other numbers show up in pairs, like in row 6. There are 2 1s, 2 6s, and 2 15s.
And for rows with an even number of entries, every number shows up twice. Like here, on row 5, we have 2 1s, 2 5s, and 2 10s.
Gosh, it's true! I bet there are patterns within the patterns too.
There totally are! Now you're starting to see why I love this thing.
Do you know any of them off the top of your head?
Of course! I've been staring at it all day. But why don't we let them take a look? Afterward, I can point some of them out.
Try to fill out the first few rows of Pascal's triangle and see if you can find more patterns. Once you've thought about it for a while, come back for part 2, and Max will point some of them out.